This video will be divided into 3 parts. Number 1, why did India's Lunar Orbiter take 40 days to get to the moon, whereas the other lunar landers took a mere 4 days? Number 2, the basic process of how the Chandrayaan-3 works in step-by-step format. Number 3, a very short comparison of the Russian Luna 25 lander, why it might last more than 1 lunar day. All in the videos ahead, so don't miss a beat. Presenting the billion-dollar question, why did they require 40 days for the Chandrayaan-3 lunar exploration mission to reach the southern pole of the moon? In contrast, China's Chang'e 2, launched in 2010, only took 4 days to cover the distance between Earth and the moon. The Soviet Union's Luna 1, the pioneering unmanned mission that came close to the moon, accomplished the journey in a mere 36 hours. Even Apollo 11's command module, Columbia, which carried 3 astronauts, reached the moon in just slightly over 4 days. While the ISRO program has a budget of just $75 million, which is the main reason they have to use the ingenious method to lower costs by implementing the gravitational pull of the moon and the Earth to get to its destination because of its less powerful rockets. The Chinese Chang'e 2 cost around $219 million. Adjusted to inflation, it's over $316 million. The Soviet Union Luna 1 in the 1960s cost around $200 million when adjusted to inflation. The estimated cost of the Soviet Union lunar program in 1964 was $6 to $10 billion. And the most ambitious program, Apollo 11, cost a staggering $25 billion during the 1960s, and when adjusted to present-day inflation, it's around $200 billion. The bottom line is the rockets were not powerful enough to make a direct trajectory to the moon, possibly due to the extremely low budget, but ingeniously took the slingshot method to achieve this mission. Moving forward, let's discuss the parts and function that is required to take the aircraft to orbit. The Launch Vehicle Mark III, also referred to as LVM-3, stands as a 3-stage medium lift. It consists of the payload fairing, which can carry the Chandrayaan-3 spacecraft. Chandrayaan-3 again consists of an indigenous propulsion module, a lander module, and a rover. Let's look at the basic step-by-step process of launching this rocket. Step number 1. The rocket's functioning revolves around a staged combustion cycle, employing liquid-fueled engines for both its core and supplementary boosters. Propelling the core stage is the Vikas engines. Step number 2. Concurrently, 2 solid propellant boosters contribute extra thrust during the initial launch phase. The upper stage of the LVM-3 incorporates the C-20 engine, an indigenous cryogenic engine developed in-house, furnishing the required thrust to attain the intended orbit. Step number 3. The vehicle initiates liftoff through the simultaneous ignition of the 2 boosters. Following this, the core stage L-110 is ignited roughly 113 seconds into the flight. Both S-200 boosters burn for around 134 seconds, and separation occurs at the 137-second mark. Step number 4. The payload fairing housing the satellite is subsequently detached at an altitude of 115 kilometers above the planet, approximately 217 seconds after launch. Step number 5. Chandrayaan-3 integrated module separates from the launcher and opens its solar panels. Step number 6. It is here the module will commence orbit-raising maneuvers. After orbiting for a few hours, the module will shift orientation toward the Sun. It will make around 5 orbits around the Earth. In layman's terms, they call this a slingshot technique, using the gravitational pull of the Earth and the internal thrusters to achieve the Moon to Earth orbit path. Step number 7. It is at this stage the module will get captured in the Moon-Earth orbit. It will then use the thrusters to slow down the module. Step number 8. Lander will separate from the orbiter. Step number 9. Even after detaching, the Lunar Orbiter will still be working, scanning the lunar surface for possible landing operations. Step number 10. The lander will then initiate the deboosting procedures as shown in the animations. Step number 11. After a successful soft landing, the lander will open its door. The rover will move out to explore and conduct scientific experiments as shown in these animations. Interestingly, the Russian Luna 25 is also landing on the south pole of the moon. This is one of the coldest parts of the moon and supposedly contains water, which is liquid gold in outer space. For this reason, upon landing, the Chandrayaan-3 mission will operate for 1 lunar day. Yes, that's right, but this is equivalent to 14 Earth days, as shown in these animations. This is due to the extreme cold on the south pole of the moon, freezing all its equipment. It is because there is no sunlight to power the lander and the orbiter. But the Russian Luna 25 might survive harsh freezing temperatures, considering it uses a radioisotope device to generate heat with plutonium at night. Till then, check out the many engineering animations as we make original videos from scratch in 4K 3D animation, with just 2 people working on this channel. So please like and subscribe for more videos to come.